In this presentation, we will see how to use transistors to make logic gates. So we can operate diodes and transistors as on-off devices, and that's going to make them ideal for building logic gates. So for something to be a logic gate, it has to have input and output. The input has to be interpretable as a logic value, as a 0 or a 1, as a low or a high, as a false or a true. And similarly for the output, should be able to be interpreted logically. So it should be clearly low or high, 0 or 1. Some of our standard logic gates are the NOT, the AND, the OR, the NAND, and the NOR. A two-input AND gate takes in two binary inputs A and B, so the A and B can be either 0 or 1, and it produces an output Y. And Y is only 1 when both A and B are 1s for an AND gate. A two-input OR gate takes in two binary inputs A and B, and it produces an output of 0 only when A and B are 0s. The NOT gate takes a single binary input and gives us the opposite. So when you put in a 0, you get a 1. When you put in a 1, you get a 0. The NOR gate is an OR gate followed by a NOT gate, or the inverse of an OR gate. And so it's got two binary inputs, A and B, and it gives a 1 only when the inputs A and B were both 0. The NAND gate is an AND gate followed by a NOT, or the inverse of an AND gate. So it has two binary inputs, A and B, and it produces a 0 only when the inputs A and B are 1s. So let's look at the following circuit. We have two transistors, three resistors, and two switches. So the switches A and B can connect to high or low, so they are our binary input. Each A is connected to the base of the transistor on the right, and input B is connected to the base of the transistor on the left, and the collectors of those two transistors are connected and at the top, and the emitters of the two transistors are connected at the bottom. So if you're thinking about the collector-emitter parts of the circuit, we might think the transistors are sort of effectively in parallel, that there's a connection on one side and there's a connection on the other side. And then there's all these resistors. So between the switch and the base, there's a resistor, and between the battery at the top and the top of the two transistors, there's another resistor. Okay, so right now A and B are low, so we're applying no voltage to the base, so those transistors are effectively off and not conducting. When transistors are off, the transistor has the effect of a very high resistance. So I have two resistors. The transistors act like resistors that are very high resistances. And so I have two resistors that are very high in parallel, so that's still high. And then I have that one single 1 kilo ohm resistor above it. So most of the 5 volts is dropped across these high resistances. So I put in two lows and got a high voltage. That's one of my 4 states. So now we're going to put in a state where A is low, but B is now high. So the transistor that connects to A, the one on the right, is getting no current and is off, but the one on the left connected to B is getting a current and is on. the effect of a transistor being off is that it has effectively a very high resistance, and when the transistor is on, it has a very low resistance. So the resistor on the right has a high resistance, the transistor on the left has a very low resistance, and those resistors are effectively in parallel. And so if there's an easy path, because they're in parallel, the overall effect is easy. So those two transistors give a low resistance overall of the parallel combination. And so we see in the sort of collector emitter part of the circuit, we have the 5 volts. It goes through the 1 kilo ohm, and then it goes through these two transistors in parallel. They have now the effect of a low resistance, and so most of the voltage is dropped across the 1 kilo ohm resistor, and only a little bit of voltage is left to be dropped across the transistors. And so we've put in a low and a high, low for A, high for B, and our output across the parallel transistors, which we're considering the output of the circuit, is now low. It's in the millivolt range. That's low. This circuit is pretty much symmetric in A and B, so now we're putting in A is high and B is low, so we get pretty much the same result. So the high and the A is leading to the transistor on the right and turning it on, giving it an effectively low resistance. The switch B is connected low, so there's no current going into the transistor on the left, making it off and a high resistance. But these two now effective resistors, one high resistance and one low resistance, they are effectively in parallel, and so the overall effect is a low resistance, just as it was for the previous state. So in the path of the battery from the 5 volts through the 1 kilo ohm resistor at the top, and then it goes down to these parallel transistors that have the effect of a low resistance, most of the voltage is dropped still across the 1 kilo ohm resistor, and there's only a little bit of voltage left to go through the transistors, and so that voltage is low. So we put in A is high, B is low, and our output for the circuit is low. Our final input state is to put in two highs. A is high and B is high. So switch A being high gives a current through the transistor that is on the right. Switch B being high gives a current through the transistor on the left. So both of the transistors are on. When transistors are on, their effective resistance is low. So now I have two transistors acting as resistors with low resistance, and they're in parallel, so that makes the effective resistance lower yet. And so in the 5 volts goes through the 1 kilo ohm resistor, and then these two low resistance acting transistors in parallel, and so most of the voltage is dropped across the 1 kilo ohm, only a little bit of voltage is dropped across the two transistors that are both on and in parallel. And so we put in high, high, A high and B high, and our overall output for the circuit is a low voltage. So let's recap our results. When A was low and B was low, our output was high. When A was low and B was high, our output was low. When A was high and B was low, our output was low. And when A was high and B was high, our output was low. This is a NOR gate. So that previous circuit is the realization of a NOR gate.